To calculate a flooded evaporator, open the dedicated calculation standard called evaporator flooded. This calculation standard has preset values for this application. The flooded evaporator system of thermosiphon type uses a tank keeping the refrigerant separated in gas and liquid. The liquid refrigerant, leaving the bottom of the tank, enters the evaporator. In the heat exchanger, the refrigerant is partially evaporated and returns to the tank where it's being separated. The liquid falls to the bottom again, and the gas rises to the upper part of the tank, and then enters the compressor, and then continues to the condenser. The difference in density between the external liquid refrigerant column and the internal mixture of liquid and gas is the motor of the process. This system is driven by gravity. This calculation standard has a dedicated scope of products. Since the refrigerant is 100% liquid at the inlet, there is no need for a distribution system. So the product lines, CB and Alpha Nova, are suitable for this application, and some of the AC models also work very well. Alpha Nova must be selected when the refrigerant is ammonia, since ammonia will dissolve the copper in the CB and AC units. Let's make an example with ammonia, since this is the most commonly used refrigerant for a flooded evaporator. Start by selecting the Alpha Nova product line. The flow direction is already set to co-current in order to boost the evaporating process at the inlet. Enter a capacity of 150 kilowatt. Change the fluid on the cold side to ammonia. A general rule is to keep the outlet quality between 0.65 and 0.85 since the refrigerant is only partially evaporized, as explained earlier. We will keep 0.7 in this example. This is a medium-high efficiency application. Therefore, we set the evaporation temperature to 4 degrees Celsius, which is equivalent to 39 degrees Fahrenheit. Pay attention to the maximum pressure drop for the refrigerant. This is depending on the density of the refrigerant, the height of the heat exchanger, and the level of the tank. Typically, the maximum pressure drop for ammonia is between 5 to 15 kilopascal. For this exercise, we will enter 12 kilopascal. Press Calculate Result List. The first proposal in the result list is an Alpha Nova 76, which is a product well suited for this kind of duty.